Have you ever wondered how you can make a magnet just by flipping a switch? I mean, it sounds kind of like magic, right? But it's actually the science behind electromagnets. And trust me, they are everywhere. So today, we're going to pull back the curtain and see exactly how they work.
Seriously, think about it. You've got those giant cranes and scrap yards that can lift entire cars. Then you've got the tiny speakers inside your headphones, even your doorbell. You've absolutely seen these things in action. Electromagnets are powerful, they're versatile, and they're pretty much everywhere you look.
So what's the trick? Well, it all starts with this really cool fundamental link between two forces we see all the time: electricity and magnetism. Turns out they're not separate things at all. They're like two sides of the same coin. Let's dig into what that actually means.
Okay, so to get that connection, we first need to be clear on what an electric current is. At its heart, it's really just electricity on the move. Picture a river, but instead of water, it's a flow of tiny charged particles, all moving together. And that flow, well, that's your electric current.
And this right here is where it gets super interesting. That simple flow of charges we were just talking about, that's the whole key. That movement unlocks a powerful, invisible force. This is the big secret.
So here it is, the main takeaway. Anytime you have an electric current flowing, it automatically creates a magnetic field around it. It's just a basic law of physics. To put it simply, moving electricity creates magnetism. That's the secret link.
All right, so we get the principle, but how do we take that idea and build something really powerful? I mean, a single wire with some current has a magnetic field, but honestly, it's super weak. So how do we crank it up and go from a simple wire to, wow, that's a strong magnet, electromagnet?
Well, the secret is all in the shape. If you have a single, straight wire, that magnetic field is really spread out and weak. But if you take that exact same wire and wrap it into a tight coil, you concentrate all those magnetic field lines into one spot. You're basically stacking them up, making the whole thing way, way stronger.
So here's the whole game plan. Step 1, you start with your wire and its tiny little magnetic field. Step 2, you coil it up to focus all that power. But step 3 is the real game changer. You stick a piece of iron, like a nail, inside the coil. So why does that work so well? Well, iron is full of these tiny magnetic zones that are normally all jumbled up. The coil's magnetic field makes them all snap into alignment, all pointing the same way. This turns the iron core into a super strong magnet itself, which boosts the overall effect a lot.
And just like that, with those 3 steps, you've done it. You have a coil of wire, an iron core, and a bit of electricity flowing through it. And boom, you've got a powerful, controllable magnet. Turn the current on, it's magnetic. Turn it off, and it's just a piece of metal again. It really is that simple. Okay, I know we moved pretty fast there, so let's just take a second and do a quick recap of the most important principle. Nailing this part down is the key to, well, understanding everything about how these things work.
It all boils down to these 2 things. First, an electric current is nothing more than electrical charges moving together. And second, that motion, the simple fact that they're moving, is what creates the magnetic field. Everything else we talked about, the coil, the iron core, that's all just clever ways to make that fundamental effect a whole lot stronger.
So I'll leave you with this question. Now that you know the recipe, a little electricity, a coiled wire, and maybe a metal core, start looking for it in the world around you. From the motor that spins in an electric car to maglev trains that literally float on a magnetic field, where else is this incredible tech hiding in plain sight? The answer is pretty much everywhere.